I want to talk about phase changes. And in order to do that, it's important to recognize that there are three different phases. Those phases are solid, liquid, and gas. And what we're going to look at is how these phases change into each other. So how a solid turns into a liquid, how a liquid turns into a gas, and the reverse, how a gas goes to a liquid and a liquid goes to a solid. Okay, so let's take a look at what it means to be a solid. And let's use water as our example. So I'm going to start with ice. That's what we call water as a solid, ice. And let's take our science microscope and zoom in and look at ice on what we call the molecular level, meaning looking at the molecules within, right? We can't really see them with our own eyes, so we have to zoom in to see what's actually happening. So in this container here, if you notice, I have a bunch of water molecules, right? Water molecules kind of look like Mickey Mouse. It has one big sphere and then two little spheres that kind of look like little Mickey Mouse ears. These two are the hydrogen, and the one up here is the oxygen, right? For H2O. Two H's for every one O. So if you notice here, I've got H, I got two H's, one O, two H's, one O. So these are all water molecules. And what are some things you recognize about how they're aligned? Hopefully you said solids are aligned in a very nice organized pattern, right? All the molecules are facing the same direction. And also what you can't see here, because this is just paper, is that these molecules, they may seem like they're not moving, but they're moving ever so slightly. We like to say they're kind of vibrating in place. So a good analogy is to think of people at a concert. So everybody's sitting in their seats, nice and organized, right? Feet on the ground, heads facing forward, waiting for the concert to begin. Kind of like a solid, nice and organized, okay? Now, this solid can change its phase. Remember, there was three phases, solid, liquid, and gas, okay? And it can go into a water phase. So let's talk about what water is and what's going to happen. So let's zoom in on water and see what water looks like. So water, if you see here, now what's happened to these nice organized molecules? Well, when these, again, it's water, when the molecules get enough heat, so let's go ahead and put some heat under there. When the molecules get enough heat, they start to move around more, right? Heat, an increase in temperature, causes these molecules to gain enough kinetic energy, and they start to move around, as seen here. This picture shows molecules moving around. They're no longer organized in a nice pattern, and they're starting to kind of lift a little bit and have what's called a fluid movement. Okay? Now, these molecules might have enough kinetic energy to actually collide and bounce out of the container, right? So let's take a look at when something like that happens. If you notice here, I've got a water molecule represented by the the red oxygen, and the two white H's seen here. So same type of concept. It's a water molecule. And so these water molecules are inside, moving around, moving around, moving around, moving around. And eventually one gets enough kinetic energy where it can kind of fly out of the beaker, right? Or whatever container it's in. Where does it get that kinetic energy from? Hopefully you said, there's still heat under there, okay? So now we see what it's like to be a solid versus a liquid. How about we change the phase one more time, keep heating up the liquid, and go ahead and zoom in on gas. So what does that look like at the molecular level? Well, here we go. Look how different it is. Now the gas has completely gained enough energy to move so freely that it's starting to leave the container, and it's not sitting on the bottom anymore as you see in the liquid. The liquid is kind of confined to the bottom of the container. Occasionally the liquid gets enough kinetic energy and a molecule can disconnect from the surface and leave, as we saw a second ago, whereas in gas, molecules have so much kinetic energy where they're constantly leaving the container, bouncing around, as you see there. So what did we notice? We noticed that in order for these phase changes to happen, heat was needed. We had to put heat into each of these to get the molecules to actually start moving. So heat allows the molecules to gain kinetic energy. All right? Okay, now let's actually go ahead and put that down and talk about when my solid turns into a liquid. Okay? So we call a solid turning into a liquid melting. That hopefully you say is kind of obvious. And it's important to write, in order for something to melt, heat has to enter into the system. Heat has to enter into this system. Okay? So we add heat in. Now, I can do the reverse. I can take a liquid and change it back into a solid. And hopefully you say, yep, that sounds familiar. I know that that's called freezing. But what you might not remember is that in order for something to go into freezing, right, from a liquid to a solid, heat has to be removed. Heat is removed, okay? So let's take a look at what happens in this process. So in a solid, everything is nicely organized, as kind of seen here with these molecules, nicely organized in a row. And then the molecules start to move around and move around, right? And one is free to start going off to the side a little bit. This is a liquid, right? The important thing to note is that these molecules are very attracted to each other. These molecules have a force that keeps them together. And that force is called an intermolecular force. So let's see that drawn as a picture seen here. Intermolecular force. You'll see this concept come up again. If you notice, the hydrogen and the oxygen, as seen here, are attracted to each other because hydrogen has a partial charge of a positive and oxygen has a partial charge of a negative. Notice how I use the word partial. Okay? We represent that with the following symbol. Partially positive, kind of looks like an incomplete number 8, and partially negative, partially positive. Now this is easy to remember because we know hydrogen turns into a cation and oxygen turns into an anion. Same thing over here. Remember, all the oxygens will be partially negative and all the hydrogens will be partially positive. So the positive and negative have an attraction, as I kind of represented here. This is called an inter, meaning between, molecular, meaning molecules, force. So an attraction between the molecules, intermolecular force. So what has to happen is, in order for this solid to turn into the liquid, this intermolecular force has to loosen a bit, right? Think about what a liquid looks like. It's a bit looser. Okay, now this intermolecular force isn't going to completely break apart, because if it does, then you've got all these gases really far apart. Occasionally some of them break off and go a little bit into the atmosphere, but most of them just stay a little bit more loose and close together. Okay, what causes that? Hopefully you said heat. Heat allows these molecules to move fast enough where they can then break free. This molecule can't break free if it doesn't have enough energy, so it needs to break free. All right? So in other words, if we bring back our analogy, right, we said that we've got those people sitting at a concert, nicely organized in their seat waiting for the show to begin. And then let's say they bring on kind of like the beginning intro band that's going to open up. And this band is, you know, not the main act, but people start kind of, you know, tapping their feet, moving around a little bit. That's kind of what the liquid phase is like. Okay, and then let's say these people start to get really kind of crazy. Now the main act is on and they start jumping around and so forth, right? That's what our gas phase is like. So let's take a look at what liquid to a gas is like. A liquid to a gas is called vaporization. Liquid to a gas is called vaporization. And then we can also reverse that as well. Before we reverse it, let's just make sure we also remember that liquid to a gas requires heat being added, right? This liquid has to continuously heat up so the molecules can gain enough kinetic energy. I can reverse this and go from a gas to a liquid. How can I do that? Well, I have to remove energy. So let's do that. Right? I have to remove the energy, remove the heat. So it has to get colder. So let's take a look, right? If these are my molecules and they're gases, right, and I start to remove away the heat, then they slow down and their intermolecular forces start to connect back together, right? They slow down. They're not moving as fast. So they start to fall and connect back together. And those forces are now able to reconnect and turn them into a liquid. If it slows down enough, they could even go from a liquid, like we said, to a solid. Okay? So some important things to write down is this all has to do with the fact, phase changes has to do with the fact of either heat entering or heat being removed. Heat entering makes the temperature heat being added, which is entering, makes the temperature hotter, and so now the molecules move faster, more kinetic energy. Removing heat is the reverse process, making the temperatures colder, and the molecules move slower, and so there's less kinetic energy. That's the end of the video.